Dear students, welcome to my channel Chemistry with Sir Ehsan. Today we will learn how to solve MCQs of organic chemistry from specimen paper 2023. Let's start with it. Question number 32 starts with the MCQs of organic chemistry. The diagrams show the structures of 5 hydrocarbons. The first one is state chain, that is pentane. This one is pentane because it has 5 carbons, and structure two is also has 5 carbons. Structure three, structure four, structure five, all have 5 carbons in them, and all are alkanes. Now we have to see which 3 hydrocarbons are isomers of each other. Let's start with it. Like say, if we see the state chain, this is normal pentane. Normal means state chain. We call it as N-pentane. So in this case, we have all the carbons in a continuous chain. Continuous chain does not mean it should always be a state. It can move upward at the end or downward. Okay, now we have to see which structure 2, 3, 4, or 5 are different from this structure number 1. If we see the structure number 2, you see in structure 2, this, if we take this state chain as a main chain, and these two alkyl groups CH3 will go outside the chain. That means this structure will be different from this structure. If we move to the structure 3, the structure 3 is similar to structure 1 because all the carbons are in continuous chain. As I earlier told you, continuous chain does not mean it should be state. We will reject option number 3 because we have selected option number 1 and we will not repeat it. Now move to the structure number 4. If this is a state chain, then this will be a branch, which is also known as alkyl group. This structure is different from structure 2, and structure 2 is different from structure 1. But if we count the number of carbon atoms in structure 1, 2, and 4, you see structure 1 has carbon 5, 2 as well, 3 as well, 4 as well, but 1, 2, and 4. But if you see structure number 5, uh, if we go like this is a state chain, this is a branch. It looks similar to this one, but you see the number of carbon atoms in structure number 5, they are only 4. When we say isomers mean different structures, but same number of atoms. Same number of atoms mean same molecular formula, okay? So structure 1, 2, and 4, these are different structures, but they have same number of carbon and hydrogen atoms. So option A, which is 1, 2, and 4, it is correct. Now let's move to the question number 33. Hope you understand. If you still have some question, you can comment on on my channel. I will try to answer your question, inshallah, with full confidence. Okay. Okay. Let's read the question 33. The diagram shows a fractionating column used in the separation of petroleum. Boys, students, this is a fractionating column. In this fractionating column, you can see a crude oil has been separated into its component, which is also known as petroleum. You must keep in mind, petroleum is a useless mixture. It is not a useful mixture. It is useless mixture unless we don't separate fractions from it. Most of the fractions in it, they are hydrocarbons. So how we can separate those hydrocarbons? Through a process known as fractional distillation. What we do in that? In that, we just heat crude oil, and the vapors of the crude oil, they are sent into the fractionating column. The fractions with low boiling point, they move to the top and are distilled over there first, while the fractions with high boiling points, they move to the bottom and are separated at the last. So if no, let's read the question. Hope you understand what I said. Which row explains why fraction R is collected above fraction S? It says fraction R has been collected above S. Why is this? So as I earlier told you, the fraction with low boiling point, which are lighter, they will definitely evaporate first. They will move to the top, while the fractions with boiling point higher than the upper one will be separated at the end. So as you know, if he says that R is separated at above S, that means fraction R must be lighter than fraction S. Fraction R must have weak intermolecular forces, must have lighter, less relative molecular mass. Now let's come to keeping in mind this information which we have in our mind. Let's see which option is working for it. So which row explains why fraction R is collected above fraction S? Greater than boiling point of R is greater than S? No. Greater than the average molecular mass of R is greater than S, so it is rejected because if it is heavier, it will not go above S. Option B, greater than S? No. So option A and B, they're totally rejected because if the first column is wrong, definitely second will be wrong. So let's move to the option C, smaller than S. A boiling point of R is smaller than S, yes. Okay, now move to the next column, greater than S. No, this is again wrong. So the only option left is D. Option D, R is smaller than S. The boiling point of R is smaller than S. Yes, it is. And its relative molecular mass should be smaller than S. As I earlier told you, the fraction with low relative molecular mass, which will be lighter, will move to the top and will be distilled over there first, and vice versa. Hope you understand the option D is correct. All three options have been rejected. Now, question number 34. Which compound is an alkane? Boys, this is a very common question. Keep in mind. This type of question is not only for alkane, it can be for alkenes, it can be for alcohols, it can be for hydroxy compounds, it can be for carboxylic acids, etc. So to answer this type of question, we need to know the homologous series and general formula of homologous series. He said, which compound is an alkane? Hope you know the general formula of alkane, which is CN H2N plus 2. Which compound is an alkane? Uh, the formula which will fit into this general formula will be an alkane. So if you see this carbon 31, if N is 31, let's say, that means hydrogen should be 31 uh, into 2 plus 2. Should be 31 and hydrogen should be 31 times 2 is 62 plus 2, 64. So only option which is working for this is not A, not B, not C, not D only. D option is only correct, and as this formula fit into the general formula of alkanes. Hope you understand. Option A, B, and C, they don't fit into the formula of alkanes. That is why only option which is alkane is D. This is correct. Okay, now question number 35. Which row correctly describes alkenes? You know, the main difference between alkanes and alkene is alkanes are saturated, alkenes are unsaturated. Alkenes undergo addition reactions. Alkanes undergo substitution reactions because in alkanes there are all single covalent bond between carbon atoms. In alkenes there is double covalent bond. This due to this double bond, we say that when double bond is broken, two electrons become free, and any two atoms can be added over those free electrons which are available on consecutive carbon atoms after the breakage of double covalent bond. Okay, now let's see. Uh, Option first in column one, A is saturated or unsaturated. Which row shows alkenes? You see, as I told you earlier, alkenes are unsaturated. So option C, A is rejected, option B is rejected, option C and D, they are considered now. As I told you, alkenes undergo addition reaction. So do you think uh, when they are shaken with aqueous bromine, they don't change? No, they will change because bromine or chlorine, they can easily add up to alkenes because of double covalent bond. So option C is also rejected. The only option left is D. Why it is correct? Because it fit according to the concept of alkenes. It is alkenes are unsaturated. Yes, they react with bromine water. When bromine water react with alkene or alkene react with bromine water, the reddish brown color or orange color of bromine is decolorized. But this is a very, very important question. The difference between saturation and unsaturation can only be done chemically by using bromine water at your level. Although there are many other tests as well, but at your level, you mostly use alkene bromine water. Now move to the next question. That is 36. A carboxylic acid with molecular formula C4H8O2 react with an alcohol with molecular formula C3H8O to form an ester. Boys, you must keep in mind ester is sweet smelling product. It is formed by the condensation reaction between alcohol and carboxylic acids. So whenever we generally make, ester, you must keep in mind we always it has been considered that OH from carboxylic acid is removed and hydrogen from OH group of alcohol is removed. But this is not a hard and fast rule because the structure will stay the same. So first of all, we need to see which structure contain total carbon as present in C3 and uh, alcohol and carboxylic acid. In carboxylic acid, we have four carbons. In alcohol, we have three carbons. Altogether, we have carbon seven. And hydrogen, we have 16. And oxygen, we have three. So the part of the structure which contain carbon, and that carbon has double bond with oxygen, and on the other side, it has oxygen with single covalent bond. That part is usually come from carboxylic acid. Now, if we remove OH from carboxylic side, then this O will go with this side. So this chain, basically this part, is usually coming from alcohols. Because this structure, which contains carboxyl group C double bond O and O, each has been removed during the formation of ester. So this structure contain four carbons. Carboxylic acid must have four carbons. So this has four carbon, one, two, three, and four. And alcohol has three carbons, one, two, and three. So structure B looks correct because it justifies carboxylic acid as well as alcohol. So structure B is correct, but we can move to see the other options as well. We see option number C, it has altogether eight carbons. We must have seven carbons altogether in an ester, in that ester. Option D, we have acid with three carbon. No, acid must have four carbon as you can see from the question C4H8. Uh, Option C is rejected. Option D is rejected. So answer B is correct. Okay, now let's move to the question number 37. This is very easy. Unit, the repeat unit of a polymer is shown. Boys, polymer is a compound, is a is a complex compound formed by the combination or addition of smaller units, simple units known as monomers. Just like if we see a wall has bricks in it, bricks are monomers and the wall is a polymer. So this is a section of polymer, which is also known as repeat unit. So the backbone of this polymer is this one. It has two carbons. If we move to the options now, which monomer would produce this polymer? So what is common in polymer and monomer? We have same empirical formula. See, uh, with these two carbons, first carbon has one hydrogen and other CH3. Second carbon, which is connected to the first carbon, must have Cl and Br. It does not matter whether Br is up or down, but they are with the same carbon. Okay. Now see which option we have in monomer. Keep in mind, in addition polymers, when we make polymer, the monomers used for making addition polymer must have double covalent bond because monomer are usually identical and are unsaturated. That is why they get added up to make a large complex chain of a polymer which may contain 50 to 50,000 uh, monomers containing double covalent between carbon atoms. So see which option is fulfilling the demand. CH3 and H, CH3 and H, yes. The other structures Br and Cl. It looks correct, but we have to see other option as well. This structure contain carbon attached to CH3 and Cl. CH3 and Cl, there is no option in monomer repeating unit given. Similarly, option C, this carbon has CH3 and Br, CH3 and Br. No, this is also incorrect because this is not similar to this. If we see this Cl, if first carbon has Cl at the top, on the other side it must have Br that is not available here. Br is another carbon. With that Br, there must be Cl that is also not available. So option D is also rejected. Option A is 100% correct. If you understand. Now, question number 38. When heated, magnesium reacts with oxygen in the air to form magnesium oxide, a white powder. A student investigates the change in mass that occurs during this reaction. The student is given a balance and the three sets of apparatus as shown. In option 1, we have metal tongs and burning magnesium ribbon. Option 2, we have magnesium, we have heating system, and we have a glass tube, and we have air as well. Oxygen is needed for burning. Whenever metal react with air, mean oxygen in air, it make metal oxide. So magnesium makes metal oxide, which is a white powder. So this is, you can write like this: magnesium react with oxygen to produce magnesium oxide. Hope you know how to make chemical equation. This belongs to group 2, it is +2. It belongs to group 6, must need 2 electron. That's why -2. So there are 1 oxygen here. We have 2 oxygen here. We will put 2 here. For balance it, we will put 2 here as well. We will discuss balancing of chemical equation in some other lessons. Okay. Now, which sets of operators are suitable for this investigation? This is safe. This is also safe. So option 2 and 3, one minute. Option 2 and 3, they looks correct, because in option 2, magnesium powder cannot escape. At the same time, magnesium powder, magnesium oxide formed is in powder form. It can mm, go into the atmosphere, or it can fall. So that is why we have lid to protect, to prevent the uh, what we call it, magnesium oxide from escaping. So option C is correct. Question number 39. A student uses paper chromatography to find an RF value for iron 3 aqueous. Why it is iron 3 is written? Because iron is a transition metal. It has variable oxidation state. That is why we need to specify its charge or oxidation state. The result is shown. You can see, boys, the apparatus here. This is a baseline on which we put the colors, and the colors are separated whenever we conduct this experiment. Color from this spot move up. This is iron 3, which is reached at this point from this baseline or starting line. So this is the distance traveled by the iron 3. This is known as solute distance. And this is the distance traveled by the solvent. Both the solute and solvent, they will be taken from the same point. The distance of color Fe positive 3 as well as solvent friend will be taken from the baseline. Keep in mind, here student makes a mistake. They take the distance of the solvent from here, because usually you have seen the solvent level is below the baseline. But keep in mind, whenever we have to measure the distance has to be taken for both color as well as solvent level from the same point, that is a baseline. So which option will be correct? I have explained, whatever he is saying in these two lines. To make the spot containing iron 3 more visible, the paper is sprayed with aqueous sodium hydroxide so that a precipitate of iron 3 hydroxide is formed. Under the conditions of the experiment, the RF value of Fe positive 3 is given by 1. Uh, it should be, RF formula is distance covered by the solute in color distance over solvent distance. So what is solute distance? That is X. What is solvent distance? That is Y. Most of the students, sometimes they get confused. Either we have to write X over Y or Y over X. Boys, if you know this, that RF value is always less than 1, then you will never do this mistake. Again, I'm saying the distance of the solute and the solvent should be taken from the baseline, although the solvent level was below the baseline. So option X, X over Y, X over Y, these are two options can be considered. Option C and D, they're totally rejected because in this case, the answer will exceed 1, X over Y and X over Y. You see, iron 3 compounds are mostly, reddish brown. They are iron 3 is responsible for rust. Rusting contain iron 3. So the color of iron 3 compound, which is oxide Fe2O3, usually is reddish brown. So option B is 100% correct. Option A is also rejected because green is for iron 2. Iron 2 compounds are green. Hope you understand. Okay, let's move to the next topic. Next question, sorry. Tests on an aqueous solution of an unknown compound P are shown in the table. Test. Aqueous sodium hydroxide added, dilute nitric acid added to the then aqueous barium nitrate, dilute nitric acid added, then aqueous silver nitrate. Observation. With sodium hydroxide, we have green precipitate, soluble in excess, giving a green solution. So, green precipitates with few drops of sodium hydroxide are for either chromium, yeah, +3, or iron 2. But iron 2 precipitate is insoluble in excess, but he says it is soluble in excess. So options of iron, they have been rejected. Only option A and B will be considered. So when we say white precipitate, it can be sulfate. Barium sulfate is a white precipitate. If we are talking about a barium chloride, this is not. It is not. It is not. It is not a making precipitate. Okay, so option B is 100% because sulfate, when you combine with barium, it will make white precipitate of barium sulfate. So option B is correct. Dilute nitric acid added, then aqueous silver nitrate. Whenever silver nitrate is taken, if we have Cl, it will be AgCl, it will be white precipitate. But he is not saying like this. He is saying no precipitate. There will be a precipitate in this. The only option which is correct is B. Thank you, boys. Hope you will, gain some knowledge from this. And if you understand something, if you think you have get advantage from my lesson, please subscribe my channel. I will be very grateful to you. Thank you, boys, both, dear students. Take care of yourself. See you, inshallah, in next class. I will be doing another paper with the same pattern, but with more detail, inshallah. Allah Hafiz.